Blake, go back to your 5. The term solubility is actually a measurement. It is the maximum amount. It's the maximum amount of a solute that can dissolve into a certain solvent. Solubility is a specific measure. It's unique for every compound. So salt has a certain solubility in water. There's a certain amount of salt that you can dissolve into water. And then, Blaine, you're right. Once you reach that point and you keep trying to dissolve more salt in, the salt crystals will just sit right on the bottom of the test tube, right? They just sit there. Because there's no more room in the water for them. Every space that's available to dissolve has already been used. So they won't dissolve. And I actually need to talk about 3 terms that have to do with that. The first term, these first 2 you've probably heard of, and you probably have a good idea of what they mean already. I'll just kind of make it official here. Dilute would mean the common way, it's weak, right? It's a weak solution. It's going to have a low amount of solute. Would be a dilute solution. A concentrated solution would be sort of the opposite. It's very strong. So it has a higher amount of solute. The difference between dilute and concentrated. Here we have a dilute solution of copper sulfate. Very little bit is in there. We add some more and we get a concentrated solution. And then we add so much that we actually saturate the copper sulfate solution. Saturated means the solution is maxed out. Everything that can dissolve has dissolved. It's maxed out. No more solute can dissolve. If I were to add one more crystal of copper sulfate to this saturated solution, and I stir and stir and stir, will it ever dissolve? No, it shouldn't. We're also going to learn about something on next week called supersaturation, which is an interesting, unique situation where we can momentarily get more stuff to dissolve than we should be able to. But it's unstable and cool things happen when you do. But we'll learn about that next week. Right now I've got one question for us, and the question is, can we change the solubility of a substance? And the short answer is, yes. Yeah, you betcha.
Add more liquid.
Actually that's one we could do, is we could change the amount of liquid. We could change the amount of solvent. Right? If you have more solvent, equals more can dissolve in. We could also adjust the polarity of the solvent. So remember, like dissolves like. Polar can dissolve and then nonpolar or nonpolar. Oh, what are those little things? Yeah, I'm saying repeat from above. That's a shortcut while you take notes. If you're like writing the same thing, write it in the exact same spot. Little quotes to mean. Just take what's right above it and drop it down. Another way is the pressure actually can change how much can dissolve, which is interesting. It doesn't affect solids, but you can dissolve gases into liquid, right? That's oxygen is dissolved in. Carbonated soda, right? Carbon dioxide that's dissolved in there. Higher pressure can allow more gas to dissolve. Higher pressure allows more gas to dissolve, but it does not affect solid solutes. Does not affect solid solutes. Higher pressure can allow more gas to dissolve. It doesn't affect solid solutes. And the last one, the final one, is the one that we're going to use next week, and it's going to be the more difficult thing to get our head around. So focus in real quick. Temperature is the other thing that can affect solubility. A higher temperature, usually, not always, but usually more solute can dissolve. And so as you'd expect, usually a lower temp that's usually the case. There are some solutes that are not affected by temperature, and then the other exception, before we go, is that gases are opposite to that. You raise the temperature, and they can have less can dissolve. Have you ever had a Coca-Cola on a warm day and had a warm Coke? Mm. Was it carbonated or real flat? Oh. Because the warm solution can't hold carbon dioxide anymore. So let's go with carbon dioxide that's flat, real quick. That's why you keep sodas cold. It's part of life. Okay. Got it? Mm-hmm. Fantastic work, everybody. Thank you so much. I'll see you next week.